So hi everyone. Today we'll try to understand the codes for that can be used to code out a CGAN, that is conditional GAN. So the data set that I would be using is shoe versus sandal versus boots. So you can see the sample images. So one class belongs to boots, other is for sandals, and other is for shoes. Now, giving you a brief about conditional GANs. So I have already covered it extensively in my previous video, but you have missed it out. So do go and watch it. So conditional GANs are basically vanilla GANs, but with a slight updation, that is you can now provide the class for which you wish to generate new samples. So in case of vanilla GAN, this was not an option, like it used to generate random images over the whole distribution over which it is trained. But in case of CGANs, we can now provide the class name for which we specifically wish to generate the image. So this is how CGANs is different from vanilla GANs. So let's get started now. First of all, we will be importing all the required libraries. I think majorly TensorFlow, some libraries around images, and NumPy. Now, next is to create a dictionary for each class for assigning each category an integer value. So now coming towards the real meat, preparing the real data set. So in this real data set, the logic that I have followed is first of all, I would be iterating through the dictionary that I have created and then reading all the files according to their particular category that I've read. So, for example, when you would be unzipping this particular data set that I'm talking about, shoe versus sandal versus boots. So, eventually, on unzipping it, we will figure out that it will create three folders with each category of images in a particular folder with their names. So what I'm doing is I'm reading through this dictionary one by one, and depending upon the key that has been read, I'm reading all the images from that particular folder. So there's some slight pre-processing that I'm doing. First of all, I'm reshaping the image into a size of 28 into 28, resizing the image, because I think else training this whole model on my local system would be very difficult. Then I'm converting it into a single channel image using convert L, and then finally I'm also converting the data type of the image to float 32, and then returning a list with the all the training images that have been pre-processed alongside their labels. That is basically the class labels. Now, coming towards generating different utility functions for the GAN model. So basically, the first function is generate real samples. So this function does nothing but it takes the data set that we have read earlier from the folders after unzipping the shoe versus boots versus sandals data set, and then randomly sample some samples out of it and assign a label one to all the samples. Why we are assigning label one? Because these are the real samples that the model will see. So if you are getting any kind of, I think I would suggest you to go back to the conditional GAN video first before coming to the codes, as I've explained every logic there itself. So here I would be randomly sampling some samples from this particular dataset that I've read and assigning label one, that is the real image, to represent that they are real images. Now next I would be explaining the architecture for the generator network in conditional GAN. So it is nothing but, first of all, what we would be doing, we would be passing a list of the image as well as its label. So it would be a list of two elements, the image and its corresponding label. So this label I would be first converting it into an embedding, then I would be expanding that embedding using dense and then reshaping that embedding. So first of all, I would be converting the label into a 2D image. Similarly, for the random noise vector, I would be expanding the dimensions and converting it into a multi-channel image, and then concatenating that particular label image that I have converted into a 2D image into that random noise image. Here you can see with this example, with this particular code snippet, concatenate the random noise image. So we are getting a random noise vector, we are expanding that random noise and then finally reshaping it into an image. Similarly, the labels are also getting reshaped into a 2D image, and then I'm concatenating them together so that the generator can get an information about the class about which it has to generate an image for. The rest of the code is pretty easy. So we would be upsampling this random noise to convert it into a relatable image given the label using conv to transpose layer, and then finally using a leaky ReLU activation function, after which converting the final image into a one channel image using con2d. So the model input would be the latent noise vector and the label alongside it as a list, and the output would be a real image, a meaningful image given the label. So if the class label is shoe, so the output layer is expecting a image around shoe. So this is how we will be generating. We will be building out a generator. So the generator has majorly to con 2D transpose layer and followed by con 2D layer. So in this we would be first reshaping the both label and the random noise and then eventually applying this con 2D transpose layers. The next two important function that we have declared is generate latent vector and generate fake sample. So the latent vector generate latent vector means nothing but to generate random noise, a function to generate random noise alongside some random label for that random noise. So for this is basically for training purpose. So here, as you can see that we are generating a random vector, then reshaping that vector according to the total number of samples for which we need to generate. So if we wish to generate 100 samples, so first we need to generate random 100 random vectors, and then and then again I would be generating 100 labels for these 100 vectors that we have generated and then assigning them together. This is majorly used for training purpose. And generate fake samples. So using the generate latent vector function that we have declared earlier, we would be generating a batch of random vectors alongside label and then feeding this random vectors and labels to produce meaningful images using the generator, and then assign label 0 to all this complete batch. So you're getting my point. In previous function what we did, if you remember, generate real samples, we were reading the images from the dataset itself and then assigning them label 1. And now in case of generate fake samples, so we are generating some random vectors alongside labels, feeding this to the generator, and then anything that is coming out of that generator is taken as a fake sample. Right, this is majorly for training the discriminator part. Now building on the discriminator. So discriminator, similar to generator, also intakes two values. One is the image generated by the generator alongside the label that has been assigned by the generator. So it is nothing but, again, we here we would be again using that label, we are converting that label into a 2D image and then concatenating that image into the image provided by the generator. I think you don't need to confuse the two images. One is an actual image generated by the generator, and the second image is the label embedding that we're converting it into a 2D image, so that the class information is provided within the image. I think if you are getting any confusion, you can refer to my previous video. So once the label is concatenated with the image generated by the generator, we are making a very shallow classification network for using con 2D layers, which gives us a classification around 0 and 1. So 0 means the image is fake according to the discriminator, and 1 means the image is real according to the discriminator. Now building out the final CGAN model. So the CGAN model will use both the generator and the discriminator model that we have described earlier. So in this case, the first of all, the discriminator model trainable equals to false. This is done because when you will be training in the coming sections, you will see that we are training the discriminator separately as compared to CGANs. That is why the trainability set is false. Now, CGAN does nothing. It defines a discriminator model using the generator output and generator label. So the output coming out of the generator and its label are fed to a discriminator. This gives us a generator GAN output. Basically, the final CGAN model is this particular line model: generator noise, generator label, comma GAN output. So what it does, keep basically the input is a random vector alongside the label for which we wish to generate the image, and the final output is 0 or 1 that is given by the discriminator. So you're getting my point, right? We feed in a random vector and label. The generator generates a fake image alongside the class label. That class label and the fake image is fed to the discriminator, and then finally the model is compiled using the output of the discriminator as an output, and the input becomes the input of the generator. So the input for CGAN is the input of the generator, and the output for the CGAN is the output of the discriminator, right? This is something that we need to remember. Now comes the training loop. I think the training loop isn't that complicated. So first of all, we will be generating a batch of real samples using the generate underscore real underscore samples function that we have declared, and then training the discriminator on the real data set first. So once we generate the real samples, we may wish to make the discriminator to train on the real samples first. Then we will be generating some fake samples and then again train the discriminator on the fake samples. So what you can do is you can also mix the two batches and train the discriminator just once, rather than calling a discriminator train on batch twice. Once the discriminator is trained on both types of data set, one is fake and one is real, then finally would be training the GAN model on just so the GAN model training is a bit tricky here. So as we are training the discriminator separately, so we won't be requiring any false samples. So what the CGAN model is getting trained on is basically we would be inputting some random vectors alongside the random labels that we've generated, and the output of the model would be taken as 1, right? So if you look, I think this can be a bit complicated. If you read this particular section, the ideal case for CGAN is whatever input it gets, right? A random vector alongside the random label, the discriminator should give an output equals to 1, making sense because we wish to make the discriminator believe that the images generated, we wish the generator to produce such good images that the discriminator takes it as always a real image. So as we're training a discriminator separately, while training CGANs, we are assuming that the discriminator is at idle position. So it has already been trained, and whatever result is given by the discriminator is the final result, is the best result it can give. So basically, if the expected output while training CGAN with random vector and image labels is 1, so this means that we are able to convince the discriminator that the all images generated by the GANs is real. Hence, we are making the generator to train in such a way that it is able to generate images in such a way that the discriminator gets fooled and takes them as real images. So this is how the training is done. Basically, I think you need to go just sit for a minute and understand the logic. You will be able to get it. It's not that difficult. Apart from that, final part is once we are done with the training part, we would be generating some samples for given classes. So basically, here we have declared our function for generating plots. It is very easy. The second function that we declared is generate latent vector depending upon class. So you give it a class label, and then it will generate some random vectors and assign that particular class label only with this random vector, so that when we will be feeding that random vector and the class label to the generator predicts images for the particular class only. So here I have tried to generate images for all the three classes. As I haven't trained the model after 3 epochs, I think it's a very less training because my local system wasn't supporting that. We have got some fairly good results, but this can be improved significantly. So you can see the images for sandals, for shoes, and for boots. So you can see that boots are pretty much recognizable now as compared to shoes and sandal. I think if we extend this training, this will have been improved a lot.